Smart Child Zone presents. Matter is everything around you. Atoms and compounds are all made of very small parts of matter. Those atoms go on to build the things you see and touch every day. Matter is defined as anything that has mass and takes up space. All the buildings, the bridges, the atomic particles are all matter. Even our DNA, the air, the molecules inside our bodies, everything is matter. Based on its physical state, we can divide the nature of matter into three major categories. Mass is the amount of matter in an object. You might have a small object with a lot of mass, such as a statue made of lead. You might have a large object with very little mass, such as a balloon filled with helium. Mass is measured in kilogram. Density is the amount of matter in a given amount of space. An object's density depends on its mass and volume. An object's mass is the total amount of matter it has, while its volume is the amount of space it takes up. Imagine a block of styrofoam and a block of wood with the same volume. Each block takes up the same amount of space, but the block of wood has more mass. Which is more dense? The block of wood has more mass in the same amount of space, so it has a higher density than the styrofoam block. Density is given as mass divided by volume. A tin box has a volume of 68 cubic cm and a mass of 544 grams. What is its density? You know the mass and volume of the tin box. Use the equation to find its density. The tin box has a density of 8 grams per cubic centimeter. A gold coin has a volume of 2 cubic cm and a mass of 38 grams. What is its density? First, replace mass and volume with the given values. Then, solve the equation. The gold coin has a density of 19 grams per cubic centimeter. We can find mass from density and volume by using the formula mass equals volume times density. For example, we have a diamond with volume 5000 cubic cm and density 3.52 gram per cubic cm. Find the diamond's mass. To find the diamond's mass, we multiply the values. We can also determine mass with force and acceleration by using Newton's second law of motion, which states that force equals mass times acceleration. Tara took a 20-gram ice cube out of her freezer. She put the ice cube in a cup and covered the cup with a lid. She left the cup at room temperature for an hour. When Tara came back, she saw that there had been a change. The cup had both water and ice in it. There were 10 grams of ice and 10 grams of water. Look at the graph and answer the question. First, find the bar showing the mass of the ice before the change. Use the scale on the left to read the value of the bar. The mass of the ice before the change was 20 grams. Next, use conservation of matter to find the total mass of the ice and water after the change. We know the total amount of matter is conserved. So after the change, the mass of the ice plus the mass of the water must also equal 20 grams. You can check your answer by reading the values off the graph. For more videos and other useful materials, visit us at www.smartchildzone.com/videos. Register your child and have access to our unlimited number of question and answer exercises. Visit www.smartchildzone.com.